Okay, so I'm come back with chapter 1, part 2. We talk about logarithmic function. Um, so we know about exponential function from previous chapter 1, part 1. Um, so which is fx equal to b to power x with b greater than 0 and b not equal to 1. So do you remember that B is base, right? Um, and also we did learn about the inverse function last time, right? So the question is, what is inverse function of the exponential function? Okay, so that gonna be the logarithmic function. Okay, so then we call inverse of the exponential function is logarithmic function, and it's with going to be with the base b and denote by log base b. So we have log base b equal to y can be converted to be in the exponential function in exponential form as b base b y equal to x. Okay, so remember that if you have, let me write like this so you can see. So log base b of x, right? If you equal to y, right? If you want to convert it to be the exponential form, so you're gonna start with base b. Okay, you start with base b over here. You say base b to power. Okay, remember this guy is power. Okay, the other hand side of the log is power. Okay, base b power y will be equal to x. Okay, so that is the reason why we have the exponential form for log is here, base b to power y equal to x. Similarly, we have log base 10 of x equal to log c, and then if we convert it, it's gonna be this is a typo. It should not be, it should not have, it should have, it should not have the log here. Okay, so let me, so it should be like log base 10 of x equal to c, right? And as you do before, you will have, let me clean this up. You will have base 10 raised to power c, and that equals to x, right? Base 10, actually, base 10 to power c equal to x. See that? All right. And remember that in mathematics, if you have log base 10, we can have like a short way to write it as just log of x, because the base 10 now should become like a hidden. If you see something like log of x, that means log base 10 of x, something like that. All right. And similarly, for the log base log base e of x, Okay, log space e of x, which is a log space um, which is a natural log. Okay, so this one called natural log, and we actually can write it in a short way as lnx. Um, and if I make it equal to c, then it's actually mean that I'm gonna use base e raised to c equal to x, right? So that is what I have here as e to power c equals to x. Okay. So if we can show that f of gx, okay, so this one is um, this one is kind of like g of x is a function now become an input of f of x. So let me say in this case, let me note that f of gx over here, that mean g of x is input of f gx. Okay, so so then we have another way to notate is, which is f of f like f not g over here of x. So which is the same as f of g of x. Okay, and in another way, in another side, if I have g of f of x, so in this case, fx is the input of the function gx, and I can rewrite it as g of fx. Okay, and that's equal to x. Then the function f and g are inverse of each other because they both, let me change the other color, because they both equal to x over here. And I can say since I have to this function equal to the same thing at x, then I can say f and g are inverse of each other. Okay, now we're gonna using log probability. It can be shown that fx equal to b raised to x and g of x equal to log base b of x are inverse of each other. Okay, so if I want to write this out over here, okay, let me write for you to see. Okay, so I have in this case I have like f g of x. What is that gonna be? I know that fx was b to the power x, right? B to the power x, but x now is input, right? And I have to change it to be g of x, but g of x was this guy, right? So I'm gonna rewrite it as log base b of x. And if you using the log properties, this is one of the log properties. That's if you see base b to power of the log with base b, then is will right away just equal to the argument, which is x. X is argument of the log on the exponent. Okay, so that's going to be equal to x. Also, you have g of f of x. What is that going to be? You have g log base b of x will be change the x, because now we have input of mx will be uh, will be where's mx bx b to power x, right? And if you still remember the properties of the log in pre-calculus or the class before this class, you should know that this will give you in the property of log, that's log base base say by b with the argument is in the exponent form uh, uh, of base b and raised to power something. So that's going to give you just the power of the argument, which is x. And as and you see over here, f of gx equal to g of fx equal to x, and that from there you can say that f of gx and sorry, f of x and g of x, they are inverse of each other. Okay, so now let's take a look at the graph down here. You see that the blue curve over here, which is y equal to b to power x. In this case, you should know that b greater than 1 because it's growing, right? Or we call it uh, go exponential function, right? Um, so this I should mention that the intersection point here is always gonna be 0, 1. Okay, all the way past 0, 1 is a y intersection. Okay, and it's increasing rapidly, right? Okay, so I say rapidly increasing. Okay, and what about the line go down here? It actually will never go over x-axis. It just go along with the x-axis, right? So you should know that the x-axis in this case is as asymptote. Oops, asymptote. Okay. What else? Slowly increasing. Slowly increasing for this graph, right? You see that? Because it's just increasing, but it just go slowly, not going upward the um, like the exponent one. So I would say this is slowly increasing. It's like opposites, inverse of it, right? Inverse of it. All right. And also this is the graph of y equal to log by b of x, which is exactly inverse of the function y equal to b of x, b is for x, right? And we have b in this case greater than 1, okay? For the asymptote, instead of the x-axis going to be asymptote in this case. In for the for the log function, I have asymptote will be the y function, the y axis. So I say asymptote. Okay, and is always past the x-axis at 1 0 1 0. Okay, all the way past. Okay, so let's talk about the domain of exponential function. As I mentioned before, the domain of the exponential function has to be from negative infinity to positive infinity, and the range of it is always has to be 0, from 0 to positive infinity. Okay, so don't forget it. Now, what about the logarithmic function? It actually like inverse of it, so you can just derive that. The range of the exponential function will be the domain of the log function. Okay, so domain of log function will be from 0 to positive infinity, and the range of it is going to be from negative infinity to positive infinity. Okay, cool. So let's move on. Let's try to do exercise number 3. Write the following logarithm equation as equivalent exponential equation. All right, so I have log base 10 of 1000 equal to 3. So remember that I'm start with base 10, right? If I try to write it with the equivalent exponential function, I'm gonna have base 10 raised to 3 equal to 1000, right? Easily. So that's it. Okay, similarly for the problem B, I start with base 3 raised to 2 equal to 9. Yeah. Okay, last one. What is base of natural log? E, right? Base E raised to 0 equal to 1. Okay, So as I mentioned with you before, yeah, from my name, right? If you see anything locked by with anything, uh, um, let's say locked by b of 1 is will always equal to 0. Okay, doesn't matter, right? It has to be that, because if you change it to be exponential form, you know that b raised to 0, what is that equal to? Equal to 1. Okay, what else? Exercise number 4. I'm gonna go by another way. Now I want to go back with a log equation. Okay, so this, what I should do is I'm gonna start with the log first, right? And then I'm gonna write down the base. What is the base right now? Oh, I know from the exponential function, base 4 here. Okay, and then I know that the other hand side gonna be the power, which is 3. So then the argument should be 64. Is that easy? Okay, let's try the next one. I have logs base e, right, equal to the power of 2.718. I should have approximate better, because you see that. And I can also change this log base e by the format ln instead of write down base e. It should be the same, but just another way to write. Equal, approximately equal to 1. Okay, last one. Log base 3, right? So base 3 of what? I do it later. I'm gonna put equal to the power with negative 2. So that should be 19 over here. Okay. Or you can also like go back the way, like, okay, logs by 3 of 19 equal to the power, something like that. But well, you can, yeah, whatever you like, you can go. But yeah, that's the way I usually do. Okay, so let's move to the next page. And I have some reminder for you from previous classes, such as um, Math 115, Math 120, or Math 118. If you have learned those class, you should know all these things. So firstly, logs base b of x equal to y, I'm gonna convert it to be base b to power y equal to x. And then we learn about the four main properties of log. We have x and y are positive. Okay, so I just want to make sure that you guys know that from, if you want to go by from the left to the right, it's gonna help you to expand the logarithmic, the logarithmic function. if you go from the right to the left, then um, then it means you are condense the logarithmic expression. Okay, so yeah, so there is some example over here. uh, for the first property, log of x of y going to be equal to log of x plus log of y. So that can be an example as log 5 times x will be equal to log 5 plus log x. Okay, so remember that log of 5 plus x will not, you cannot write it as log 5 plus log x. Okay, you cannot do that. Remember that. Okay, it is like very dangerous one. So I just want to make sure you guys don't mess up with that. Similarly, for the log, the log of x over y will be rewrite as a difference between two logs over here. Remember that all base going to be the same. For this case, for this properties, so similar. So from the example, I'm gonna have log of 2/3 gonna be log 2 minus log 3. Okay. And also property number 3 here tell you that you can actually move the power of the argument here down to the front of the log. Okay, this property is really good because you can solve for some case I mean, you can using this method to solve the exponential function. Okay, yeah, and then example over here, log of x power 3 gonna be equal to 3 put down in front of log of x. Okay, and last one, the last one is just the easy one. It's just gonna remember that we have log, right? Then the arguments should be equal each other. So in here, I have log base b of x going to be equal to log base b of y. Then you should know that x equal to y, right? Similarly, log in here base for this one to be like hidden number 10, right? Then they have same base, and then that means 2x equals to 6. And then you can solve for it to get x equal to 3. Okay. All right, so now we're gonna use the law of logarithm to evaluate log base 2 80 minus log base 2 of 5. Okay, so I would like to condense to this because they are having the same base, right? You see that having the same base is 2, and since they subtract each other, then I'm gonna think about probability number 2 here to condense this. So I'm gonna have logs by 2 of 80 minus logs by 2 of 5 will be equal to logs by 2 of 80 over 5. Okay, and then it use the calculator to calculate what is 80 divided by 5 gonna be. You're actually gonna have logs by 2 of 16. Okay, So what else? You should uh, okay. So now, is there anything else that I can simplify? Um, or I can evaluate this one. There is many way for this case. I would love to to make this one equal to make this log equal to a variable, because I'm trying to evaluate it. So I just want to make it equal to x, right? And then we're going to find x, which is the value of the log 2 of log base 2 of 60, right? Okay, so we have using the definition of the logarithm, I have 2 raised to x, right? Will be equal to 16. Okay. Now, I want to make the equation here have same base, which is 2. So I'm going to change the right hand side 16 over here to be equal to 2 to power something. I'm pretty sure it is equal to 4. I mean, the 2 to power 4. And the left hand side is 2x. So then, since the equation have same base, then the power have to be the same. So x equal to 4. And that should be the answer. Or I can just say like this equal to 4 log 2 base 2 minus log base 2 of 5 equal to 4. Yep, I gotta just delete this. All right, and then circle this. Okay. Okay. So let's try to do exercise number 5. We're going to express the given quantity as a single logarithm. Okay, so what does that mean? We want to make these two to be a single. That means we try to condense, right? Condense, right? So okay, go back here. You want to condense, and it should go from the right to the left, right? Condense. You want to go from the right to the left. Okay, so we having addition between 2 log, and they are the same base, 3, right? So let's see what happened. Okay, we can using the number 1 here, right? But before doing that, make sure there is no coefficient. There's no constant in front of log. So I see number 2 here. So what I should do is I'm gonna apply number 3, OT number 3. We move the power to the front. Move the power. Move the constant in front of log to be the power of the argument. So now I'm gonna just write here log base 3 of 20 plus log base 3 of 5 to power 5 to power 2, right? Remember that. Okay, so now what? Now it's time to condense my property number 1. I have one single log with base 3, and in their addition, so then you have 20 20 multiplied by 5 to power 2. Okay. Uh, for this one, I can also use calculator and have log base 3 of 500. 20 multiplied by 25. So that's be 500. Okay, we're done with it. Now the exercise number 6 say try to exact value of the expression logs by 5 of 125. Okay. Again, these have so many ways to find the value of this. You can okay, maybe I show you 2 ways. So method 1, you can convert argument. So I have logs by 5. I convert the argument over here. I convert it to be logs by 5 of let me see, 5 to power -3. So you should know that you can use a calculator. You know that's 5 to power -3 going to be equal to 1 over 125. So since you have base of the log equals to the base of the argument, so then this log gone, and you want to have the value of this log going to be equal to the power of the argument, which is -3. Okay, and another method, and which is the one that I usually use, is I'm gonna just let this log base 5 logs base 5 of 125 equal to a y. Okay, so then you can have 5, you can change it to be the exponent form, right? So I have 5 raised to y equal to 1 over 125. Okay, so I'm trying to change one. Okay, so 5 over y gonna be equal to, I know that 125 gonna be 5 to power third, and then I change it to be 5 to power -3. And then since we have same base, then the power has to be the same, is y equal to -3. So the answer should be -3. The value should be -3. Okay. Number 7. Use the law of log to evaluate log base 2 of 6 minus log base 2 of 15 plus log base 2 of 20. Okay, so in other words, 5x, where log base 2 minus of 6 minus log base 2 12 plus log base 2 of 20. So look like we have we have 3 logs, but the same base is number 2. So I would like to think about condense this 3 log to be only one single one, so I can solve it easier. Okay, so I condense this, the first 2 first. Right, I go from the left to the right. So I have logs by 2 of 6 divided by 15. Plus with the logs by 2 of 20, which x. Okay. So I'm gonna using the first property and condense these to one. I have log by 2 of 6 times 20 divided by 15 equal to x. Okay. So if you know how to if you know oh if you know let me see, right. If you know how to simplify this 20, actually you know what, I can let me do one more step for you to see it clearly. So I have logs by 2 of 3 times 2, 6 equal to 3 and 2, and multiplied by 5 times 4, which is 20, divided by 3 times 5, which is 15. I factor it out because I can easily cancel the common one, which is 3, 3 here, 5, 5 here. So now I will just have logs by 2 of 2 times 4, which is 8, equal to x. And for this one, it's kept easily. You can change the argument to be logs by 2 up 2 to power 3 equal. You know what? Let's just follow because I know that I did use the x here, so that's okay. Just equal to x, and then you should know that the left hand side now become just 3, and the right hand side equal to x. Okay, so the value should be equal to 3. The value of these 3 things. All right. Let's go to the last page. So what are the logarithm root for? So one of the main use is for finding exponents, right? What else? Use property, natural log e to power something, a box, right? Equal to the box. And log by 10 of 10 to power a box, going to be just equal to box. So remember that this actually is come from the property, say that logs base b of b to power x will just be equal to x, right? So yeah, the box is in here. It's actually like an x, okay? Right. Okay, so now let's do example 6. We're gonna solve e to power 5 minus 3x equal to 10. Okay, so now the problem is we are having all the variable is on the power, right? So what is exponential function or exponential equation? How can you solve it? You actually have to use log, okay? You actually have to use this properties in order to solve this problem, okay? So you can in order to cancel the e here, you can apply ln, right? Yeah, both hand side. So let's do ln both hand side. So ln e to the power of 5 minus 3x equal to ln of 10. Let me have a parenthesis here to make sure. Okay, now since you apply the formula from ln e to the power x going to be equal to just x. So I mean e to the power something, right? Ln of e to the power something going to be just that thing. Now that's just the power up here. Right? So left side going to be just 5 minus 3x. And the right hand side going to be ln of 10. So now it's easily, you can just subtract both hand side by 5. You have ln 10 minus 5. You know what? I would say, let me go another way. Let me, yeah, I'm gonna move 5 and then multiply by -1. So I'm gonna have 3x here and then 5 minus ln x, ln 10. Okay, so now you will have x equal to 5 minus ln 10, everything divided by 3. Okay, so that should be the solution. Change that color. Okay, let's move to example 8. Let me change. You know what? Yeah, good. Now I have 2x minus 1. Sorry, e to the power 2x minus 1 minus 5. Again, I still have the power, the variable in the power. So what I'm trying to do now, I should try to isolate the exponent form, okay, by adding 5 both inside, right? In order to, okay, remember that you need to isolate the exponential form first, okay? So I want to have e power 2x minus 1 equal to 5. What else? Have 2x. Yeah, you know what? I just slow down and put ln both hand side. 2x minus 1 equal to ln 5. I take ln both hand side, right? Now I'm gonna have the left hand side gonna have only the power because the ln base e will cancel with base e of the exponent. Right hand side gonna be 5. And then finally it's just gonna have x equal to 1. Oops, 1 plus ln 5 divided by 2. Okay, so that should be the solution. Okay. Lastly, so exercise number 9, solve for x in the equation ln x plus ln x plus 5 will equal to ln 6. Okay, so we have the question is A, combine the two log term in the left into one log term. Okay, combine it means condense. Okay, condense the two log term here, and why the new equation. In order to combine, you should know that this addition between two same base log. So you're gonna just condense it to be 1 ln, and addition that make that to be multiplication of the argument. So x times with x plus 5, that's will be equal to ln 6. Okay. So use priority 4 to write an equation that doesn't involve logarithm. Okay, so you see that both hand side have natural log, and then it means the argument has to be the same. So I'm gonna write as x times x plus 5 equal to 6. Okay, so then they say move everything to one side of the equation and then factor this quadrant. Okay, so actually I should distribution first. I have x squared plus 5x equal to 6 for the part B. Also, now for part C, if I want to move everything to one side, I have x squared plus 5x minus 6 equal to 0. So then now, if I want to factor this, you should know the AC method for the quadratic that have a equal to 1. So that's AC equal to A of C equal to negative 6, B equal to 5. Two number that multiply equal to negative 6 gonna be say negative 1 and 6. And addition equal to 5. Okay, that's satisfied. So I will have easily that x minus 1 times x plus 6 gonna be 2 factor that I want. And then I have then I just gonna have using zero factor properties to have x minus 1 equal to 0 or x plus 6 equal to 0. So then the answer should be x equal to 1 or x equal to negative 6. And that should be the answer. Part D says substitute the value x back into the original equation to make sure they are valid member of the source of the domain. Okay, so let's try x equal to negative 6 first. I put into it, so I have and negative 6 with the first term. I say, oh, that doesn't work because argument become negative, so not in the domain. What about x equal to 1? I have ln1 plus ln1 plus 5 equals to ln6. Yep, that is good one. Because ln1 plus ln1 plus 6, 5 going to be 6. And then combine it's going to be 6. Yep. So solution is x equal to 1. Okay, so the last example over here is say evaluate log base 8 of 5. Okay, let's finish this quickly. I have I can chain. No, they say that this is using the chain of the base formula. Okay, over here. So this one also important for you guys because why? Sometimes if you want to calculate this on the calculator, you cannot do that. Okay, because on the calculator you don't have the base number 8. So what you should do is you need to use chain of base formula. Okay, so which is log by a of x and equal to log equal to ln x over ln a. So the x, the argument now become the argument of ln on the top, and the base going to be the argument of the ln at the bottom. So so now I have ln 5 on the top and ln 8 at the bottom. So you should know that if you use a calculator, there is ln button, so you can find it, and it's approximately it's be 0.774, right? So that's be okay. So we're gonna stop chapter 1 here, and we'll see you in chapter 2. Bye.